Let A and B be two vectors, and I represented vector A horizontally, however it's not necessary. We know that this piece is the scalar projection of vector B onto vector A. Now let's consider a vector that is parallel to vector A and has magnitude equal to the scalar projection. This vector is denoted by orthogonal projection of vector B onto vector A. Now let's learn how to determine this new vector, that is the orthogonal projection. Let's consider another vector here. So we may write, I'm gonna call this new vector as B2, and the orthogonal projection is gonna be B1. So we may write B2 plus B1 is equal to B. And we also may write that B2 is equal to B minus B1. But we know that B1 is parallel to vector A. So we may write B2 is equal to B minus a scalar number I'm gonna call C times vector A. Now let's multiply both sides of the equation by vector A. It's gonna be a dot product with vector A. So we may write B2 times vector A, or dot product between B2 and A, and on the right side we're gonna have B minus C times A dot vector A. But we know that vectors B2 and A are orthogonal. So the dot product between these two vectors is equal to 0. So we may write 0 is equal to B dot A, and here we are going to have C times A dot A. 0 is equal to B dot A minus C times the magnitude of vector A squared. If we leave the scalar number C alone, we're gonna have C is equal to dot product between B and A over the magnitude of vector A squared. We wrote that vector B1 is equal to C times A, so we may write vector B1 is equal to C that is equal to B times A over the magnitude of vector A squared, this times vector A. So B1 is the orthogonal projection of vector B onto vector A, and this is how we determine this orthogonal projection.